So we're going to start with the confidence interval for the mean, which is in 9.2, because I think it's a little simpler to do than the 9.1. All right, here we go. So going back to the question, suppose you want to estimate the mean number of hours that college students are working per week. You could take a survey of 200 students and ask them how many hours they worked last week. And this is called, this sample estimate, X bar, is a mean of your sample, and it's called a point estimate because it's just one point of data. And again, when you're using sample data for estimating the population data, there's a possibility that your random sample doesn't reflect the population, and this is called error. So what we want to do is have a normal distribution. So we're going to make sure that we have the initial conditions satisfied. Now, the way we're going to construct a confidence interval is a little different than what we did with the sampling distribution in the last chapter. So this is actually going to work regardless of the shape of the population or sample size. So in order to allow for a more precise estimate of a parameter than just the point estimate, we're going to use a confidence interval estimate and a margin of error. A confidence interval for an unknown parameter consists of an interval of numbers based on the point estimate. Remember, a parameter is that population estimate we're trying to get. So in order to have a confidence interval, we're going to have an interval of numbers based on the point estimate. It has a lower bound and an upper bound, and it's written in the form open parentheses, lower bound, comma, upper bound, close parentheses. So instead of just one point, we're going to have an interval of numbers.
I got cut out for a little bit.
Yeah.
Could you just reiterate the margin of error?
We're getting there.
Okay,
we haven't really talked about what it is yet. That's okay. So another way to write the confidence interval is written X bar, our sample mean, plus or minus a margin of error. And the margin of error is the number that defines the lower and the upper bounds of the confidence interval. So let me do a little illustration of what this is going to look like. So you have your X bar estimate. This is your sample mean. And based on your X bar, you're going to do X bar plus the margin of error. And that gives us our upper bound. So we're adding the margin of error here. If we go in the other direction, we're going to subtract the margin of error. And that gives us X bar minus the margin of error. And this is our lower bound. The margin of error and the upper and lower bound will be calculated in StatCrunch. There's a formula for it, but we're not going to use that. We're going to use StatCrunch. Okay. The entire length from all the way from the upper bound to the lower bound, they call the width of the confidence interval. So each time I write on the screen before I go on to the next one, I'm saving it. And then I'm able to take that screenshot and post it in our class. So you'll see it later. Okay, I can post it right after we're done. Okay. Any questions? Okay. Oh, this is what I just said. The width of the confidence interval is the difference between the upper and lower bound. So it's twice the margin of error, one on each side. So let's look at an example with numbers in it, which sometimes helps. The 95% confidence interval for the mean number of hours students work is written in parentheses 24.63 and 24.97. So this is my lower bound, and this is my upper bound. Hold on, I'm going to cough really loud. Allergies. Okay. So that's one way to write the confidence interval. The other way, in the second example, is to do the mean plus or minus the margin of error, where x bar is our sample mean, and our margin of error is 0.017. So writing that like I did on the other slide, here's our x bar in the middle. That's our 24.8. We add our margin of error, which is 0.017, and we get 24.97, our upper bound. We subtract it, 0.017 again, and we get 24.63, and that's our lower bound. And our total all the way across is called the width. And the width, you can look at in two ways. It's 2 times the margin of error. Or you can look at it as your upper bound minus your lower bound. Same thing.
Where did you get the 0.017? Like, where did you get the sample mean from that?
All those numbers, I'm going to show you how to do in StatCrunch. Okay?
Okay.
We haven't gotten there yet. This
All
is
right.
just to kind of understand the big picture of what's going on. But StatCrunch makes this super easy, no formulas. Okay? The confidence level represent the expected proportion of intervals that would contain the parameter if a large number of different samples is obtained. I know that looks like a word salad, so I'm going to help you with that. But the level of confidence is usually 95%, 98%, or 99%, sometimes 90%, doesn't really matter. The confidence level of 95% has what's called a level of significance, alpha, which is the opposite of the 95%, so 5%. So we have the confidence level, and its opposite is the level of significance. We will use the level of significance in chapter 10, so I'm just mentioning it now, and then I'll bring it up again in chapter 10. So let's think about what this confidence level means. We're using a sample to try to figure out the population. So if we have a bell-shaped curve for all of our samples, all our little X bars are in here, and we choose a 95% confidence level, that means if we take 100 different samples and make these confidence intervals, 95% of these confidence intervals actually contain the population mean. About 5% of them won't contain the population mean, but it won't be too far off. It's just that they happens to be a low sample or a high sample. This is the statement we use to report the confidence interval. We say the confidence level, the parameter that we're estimating, and the upper and lower bound. So this is our model statement. Oops. We are 95% confident that the mean number of hours that all students work is between the lower bound and the upper bound. So 24.63 and 24.97 hours. That's the way you're going to write the sentence in your solution. We're 95% confident that the mean number of hours that all students work is between 24.63 and 24.97 hours. That's the best you can do to estimate the population mean. Okay. So what does this mean again? If we're 95% confident that the mean number of hours that all students work is between 24.63 and 24.97 hours, this means if we use these methods to find 100 samples, then we have 100 different sample means and 100 confidence intervals. Then 95% of them would actually contain the mean of the population. Can we have an interval that doesn't have the population mean? Yes, because it's just one sample and it might be very high or very low, what we call extreme. So the margin of error that we talk about depends on 3 factors. First, the level of confidence. If you want to be more confident in your estimate, so you only want it to be wrong 1% of the time, so use a 99% confident to say, I want it to be right 99% of the time, the way the method works is it just makes wider confidence. So higher, 99% will be wider than 95%. So the margin of error is going to be a larger number. Larger. Okay. And that way you'll capture more times, you'll capture the population. As we know, as the size of a random sample increases, then we're going to have smaller standard deviations. And so that means the margin of error is also going to decrease. And then we're going to look at the standard deviation of the population. The more spread out a population, then the wider the confidence interval has to be for the given level of confidence. So I know this sounds really weird, so what I want to do is show it to you in StatCrunch. So I'm going to start with showing you how confidence intervals work. And then I am going to show you how we calculate them.